Okay, so again, we're going to have this due, it's going to be due on Friday, but I'm going to cross out a few of these. So here's the homework. Exercise 1, determine whether or not it okay, that's okay. So we'll go through this one a little bit. Table below represents exact, approximate, or linear. So take a look at these and see if, so my x's are going up the same amount each time, right? See if the y's are changing the same amount, or whether they're changing not quite the same amount each time. If they're changing the exact same amount, then it's exact. If they're not changing the exact same amount, then it's not exact. Everybody on board? Okay.
So across.
Sketch a scatter plot. So I would just go like this, sort of, right? And you're just going to start with -2, -2, -1, 0, 1, 2. And just pop them in there and graph them. And then here you should start with, it looks like you need to go from, you need to come from -2 to 6. Oh, hold on, whoa, wait, don't do what I did. I just realized I didn't, this is not a word problem. So let's draw your line maybe through here and maybe through here. And then 0, 0 is our 0, 0 is our line. And then we can go, this is 1, right, 2, 3, 4, 5, and 6. Oh, we don't need to go that far. We only need to go to 2. We're okay there. And then we'll have -1, -2 is here. Just to give you guys, a few spots along there. And then, these are all 1, 2, 3, 4, 5, 6. This is -2. Just so you kind of have some spots in there. And then just make a scatter plot. Right, so graph these points onto here. So for example, -2, -2. Again, you start at 0, 0. You walk first, let's do 0, I'll do this one. Actually, I'll do this one. So first I walk to the elevator, so I walk to 1, and then I go up 3 floors. Right, so that's 1 point. This is 1, 3. And actually, if you're not sure if it's approximate or not, you can always do the graph first, and then you can see. Right, that's another way of looking and figuring it out. And then find the linear function that models this data. Again, remember your b is your y-intercept. And then you got to figure out what your slope is. And ideally, 2, 6. Yeah, ideally use the first and last. Right, those are your kind of the ones you ideally want to use, the first and last point. If those don't work out very well, you can always use the first and the second to last. Great. And then, so skip this part here. Don't worry about that part, skip D. And then for this part, just see if it's the same or different. Cross out that second part. Everybody good? So cross out the second part of E. Don't worry about that. Okay. Now, this is where it gets interesting. Is this exact or is this approximate? Everyone take a look at this. Everyone take a look at the graph. Is this exact or approximate? Are those lines an exact line, or are those dots not in an exact line?
Approximate.
Not an exact line.
Not an exact line, it's approximate. Everybody on board with that part?
Yes.
So you're going to write down approximate. right? Not in straight line. And then that's it. You're gonna cross off the rest of it. Everybody good? So you're gonna skip the rest of problem number 2. Or just write this down, you're done with 2. Good? Skipping all of number 2. Okay, I do want you to do number 3. So do number 3, do this one. So again, the same exact one as the first one we did, right? Figure out, you sketch a scatter plot, find the linear function that describes it using probably, I would say, the first and the last points. And then once you graph it, you should be able to say whether it's exact or approximate. And again, this last part, don't worry about the percent change, cross that part off. This is page 3. Has everybody done this part? Has everyone crossed off that part? Mm-hmm. Okay. Now let's take a look at number 4. Sorry. We're going to skip number 4 too. Skip.
Completely.
Yep, completely skip 4. Now this one, these are word problems. You're going to create one. Does yours look exactly like this, where it says currently there are 21, do you not have this one?
What?
Oh, no, you have it.
So
Yep.
so-
Okay, good. So yeah, so this one you're going to find a linear function, right? So you have 1 point. Oh, you have the initial amount, and I've given you your change, your rate of change. I've given you m in there if you find it. So I'm telling you how much you're gaining or losing each year. That's your rate of change. That's your m, your slope.
49.
Good.
What is it, LT is a fancy name for Y again, or what? Or
The LLT, yeah, it's fancy name of what? Okay, and then number 2 we're going to skip as well. So number 2, we're going to skip this one. So we're not going to do the calculator stuff. Okay, number 3.
So skip the tables for everything.
Yeah. Number 3. Okay, so here you have a couple of spots, right? You know that 11% goes with 2004, 16% goes with 2010, but you're doing years since 2000. So 2007 is really not 2007, it's really X is 7. Do you guys see what I'm saying?
For percentages, do we translate it to the decimal, or does it say 11 and 6?
Stays at 11.
Okay.
So let me point out a couple things. We're looking at years since 2000. So it means that my X, or my T, they're gonna call it, but X is gonna be years after 2000. So we know that 11% goes with 2007. Everybody on board with that part? So that means that I have 1 point. X is 7. Y is, what's my Y? 11. So it's the similar stuff we've done before, but now I'm kind of giving you, you've got 2 points. I'm telling you the first one, 11% in 2007 is really the same thing as 7, 11. So that's my hint. As you go through it, just write that stuff in there. And then as you go through it, you should be able to solve this hopefully on your own with the homework. So you've got 2 points. You need to find a function, so you need to find your slope from those 2 points. And then you need to figure out what your initial amount was. So it's similar to that problem we did earlier. And then, assuming this trend holds, find linear function. So remember, linear function should be y equals something with x in it, right? Y equals mx plus b. Find your m and your b and plug those in. Should I write that in? This means y equals mx plus b. Find m and b. That didn't. I'll do it like this. So that's what that means. Good? Bigger? Okay. And then figure out, what percentage of soldiers are unavailable for combat in 2014. So 2014, figure out what your X is. Right? And then plug it in. Find the Y. Right, so x equals what?
14.
And then plug in to your equation. Y. Okay. So that's it for the homework. And again, whenever you guys are done or have time in class, you can pull this out and work on it. Good? Okay, so the next thing we're working on today is going to be, okay, good. We're going to start in on what I didn't think we get to. Compositions and inverse. So let's get to our composition and inverse. Oh, yep. Okay, yeah, if I skip those 2 things, then we totally have time. Okay, right, so I'm going to skip I'm skipping a couple of handouts, which means that we're definitely going to have time to get to our exam on Monday. So what we'll do is we'll start finishing up this one. This will be the last thing we do in this chapter. We'll finish it up next class. We'll start at this class, we'll finish up next class. And then next class, we'll start in on a little bit of review. So we'll review a little bit next class. We'll review all on Friday. And then Monday, we'll review for half the class on Monday. And then you guys will take your exam, and then you can head home. Good? Okay, so let's go ahead and get this one. We have two, actually. We'll have some today. We'll have a little bit today. We'll have a couple. We will have more next week. I forgot. Okay, but today and Wednesday, we should finish up those and then review all of Friday. Okay. So, the composition of, so before, remember, last chapter 2, we talked about compositions before. Remember that's when where like you add up all the things in your bill and then you compute the sales tax. We kind of had F eating G. You guys remember that F of G and G of F? We did those. So now we're going to look at them a little bit more with linear functions. Let me pause this. Or let me turn this off a little bit and restart it. So, so that composition creates a new function, right? Combining the actions of two functions into one. In introduction to functions, you learned how to form the composition of two functions symbolically. Now we're going to do it symbolically. So in other words, with the equations. So here's two functions. F of x equals 1/3 x minus 4. G of x is equal to 3x plus 12. We're going to find the functions f of g of x and g of f of x. So again, f of g of x, as soon as you get this, rewrite it immediately. So it reads f, and then this little circle is like an of, f of g of x. I'm going to do it like this.
Oh, this
F of,
the double parentheses.
yeah, what's it eating? It's eating g of x. So if you get used to doing that right away when you get it, it will make your life 100% easier. It's way easier if you do that. Okay, so I'm going to write in here, what's my f of x? I'm going to write it in right here. F of x equal to 1/3 x minus 4. So 1/3, and then every time I see an x, I'm going to put a giant parentheses, minus 4. Okay, why am I doing this? My f, I'm doing f of something. So it means that my function is f. So this is my y. This is my function. This is kind of like my x, my input. So you guys good with that part? You guys remember? This is my y, this is my x. So this is my input. So I'm going to write out my function, f of x equals, just like it should be, only everywhere I see x, I'm going to put a giant parentheses. That's, anytime we want to substitute something in for x, that's what we want to do. Put a giant parentheses whenever we get to an x. Okay, what goes inside? G of x. But what's g of x? 3x plus 12. So this is really, do you want me to do an extra step? I feel like you want me to do an extra step. F of that's that 3x plus 12. 3x plus 12. Do it like that. Is that better if I do it like that? Do you guys feel better if I do that like that? Okay. So all I'm doing is saying g of x is 3x plus 12, so I'm gonna write in 3x plus 12 instead of g of x. Do you have the handout? Okay. Does he have the handout? Alex, do you have the handout?
I don't think so. Maybe.
It's the one I just gave you guys.
Is it this one? Oh, yeah, I have it.
Okay. Good. So since those two things are equal, we're just going to substitute in this part in for g of x. So then I have f of g of x. On this side, I kind of like to write the g of x on this side, and write the g of x as 3x plus 12 on the other side. It's just, it kind of makes my answer clearer. So now I'm just going to simplify this. 1/3 times that, 1/3 times that. So what's 1/3 times 3x? What's 1/3 times 3? 1. So this is just, oh, first of all, let me ask you this. Is there anything else acting, what's acting on this parentheses? Or anything being squared or any number up top?
No.
No. There's something multiplied in the front?
Yeah.
Yes, so we can do that, and because it's being multiplied in front, once we do that, then we can take away the parentheses. Everybody all right that part? So it's being multiplied by 1/3, so 3 times 1/3 is just regular ordinary x. What's 1/3 of 12? That means multiply. What's 1/3 times 12? 1/3 of 12.
4.
Right, if I take 12, I have $12. I'm going to divide amongst the three of you. How much do you each get? $12. Split amongst the three of you. How much do you guys get? 4. Right, so 1/3 of 12 means 1/3, 12 divided by 3. It's 4. Do you guys want me to write that out? Is that better if I write that out? 1/3 times 12 times 12 over 1. Is that helpful? Is that better that way? Let's take it step by step.
So x is 1x. right?
Yep.
Oh, okay, so
1x.
if you have a 1 in front, it just drop
Yeah.
the 1. Okay.
Yeah. Usually, like if you say I have 1 apple, you say I have an apple.
Okay.
So then that just equals x.
Plus 4 minus 4, yeah.
Well, this is interesting. I have two functions. First I do g to it, and then I do f to it, and I get back what I started with. I get x. So that means that f and g, they undo each other, because I get back what I started with in the beginning. What do we call things, two functions, when if you do one thing to it and then you do the other thing to it, you get back what you started with. You get back x. Inverses of each other. So if f of g of x and g of f of x both equal x, then they're inverses of each other. It's just kind of this cool property. So let's check out this one. We'll do g of f of x. So this is g of f of x. So what was g again? G was 1/3, well, no, that wasn't. G was 3x plus 12, 3 giant parentheses plus 12. And f of x is 1/3 x minus 4. Is that right?
Yeah.
Okay. So we're gonna distribute that in. We'll get 3 times 1/3, which is 1x. We'll get 3 times -4, which is minus 12. And then you still have the plus 12 over here. When you simplify that out, just x minus 12 plus 12 is just 0. So it just goes away. So you'll notice that these are just, they both equal x. If you do both f and g, you get what you started with. Which is x. Because they're inverses of one another. Right? So sort of like A simple case would be if f was multiplied by 3 and g was divided by 3. No matter what you put in, and once you did both of them, you get what you started with, right? Because 1,000,000 times 3 divided by 3 is just 1,000,000. So everyone with me on that part? So that's the thing. If whatever x is, doesn't matter what x is, it can be any number you want. You do one thing to it, and then you do the other thing to it, you get back what you started with. They undo each other. Right? If I do this and I get something, and I do that to it, I get back I get back x, what I started with in the beginning. So in other words, if I had 1,000,000 and I put it into here, and I took that answer and put it into here, I'd get 1,000,000 back. Do you guys want me to prove that to you? Do you want me to show you? Or let's do 100. It's easier. Right, so 3 times 100 is 300, plus 12 is 312. 312, if I pop 312 into here, 312 divided by 3 is 104. 104 minus 4 is 100. That's what I started with. Any number you put in, if you put it into one and then put it in the other one, or vice versa, you'll get what you started with. You'll get x. Because the composition of the two gives me x. That is a test to see if they are inverses of each other. So if f of g of x is x, right? So that's, this one right up here. G of f of x, if that equals x, then that means that they're almost certainly they're inverses of each other. Okay. There is a 4-step process to find the inverse of g. Have we done that yet? Have we done the 4-step process to find the inverse? We haven't? Okay. So, we want to find the inverse of g. What's up with inverses? The x becomes the y becomes the x. They swap places. Everybody with me? Okay, so this is important. So here, this is how you do the 4-step process. First, g of x, is g of x my x or my y?
Y.
My y. Everybody on board? This is my y. So I'm just going to rewrite it. Y equals 3x plus 12. Everybody good with that part? That's the regular function. Now I'm going to find the inverse. In the inverse, what happens with the x and the y? They switch places, they swap. So I'm going to do the inverse. Here's the inverse. Inverse, you swap x and y. So x equals 3y plus 12. But here's the deal. Functions are always written as y equals, right? So now I've got to rewrite this as y equals. How do I solve for y? Well, what's happening to y first? First it's being what? What's the first thing? If you're y, I'm y. What do I do first? What am I doing? What's happening to me first? I'm being multiplied by what? By what? By 3. Is everybody good? So first I'm being multiplied by 3, and then what's going to happen to me?
Added by 12.
Added to 12. So if we're going to undo that, we need to undo them in the opposite order, right? So, right, socks and shoes, and then when you undo it, shoes, then socks. So I'm going to undo the last thing that happened to me. What's the last thing that happened to me, Alex?
The shoes.
Yeah, which is, in this case, is what?
Y.
So what's the first thing that happens to y? What's the first thing that happens to y?
Multiplied by 3.
Multiplied by 3. What's the second thing that happens to y?
You subtract the 12.
You add 12, which means the first thing you're going to undo is the adding 12 by doing what?
Subtracting 12.
Subtracting 12. So first I'm going to get rid of the adding 12. That was the last thing that happened to it, so I'm going to subtract 12. So I understand why? It's the last thing that happened to it. So draw your railroad for success straight down here. Make sure you draw that in there. Right straight down through the equal sign, so you make sure you do to both sides anything you do. So I'm going to do minus 12 to both sides. And then I'll have, so over here I'm going to have x minus 12 equals 3y plus 0, but that just goes away. Right, that will just,
So is it just minus 12? You drop the x, or you have to put x minus 12?
x minus 12. I'm subtracting 12.
Right, but the answer is minus 12, then, right? Or no, it's still minus.
It's x minus 12.
Oh. Okay.
You can't get rid of the x, it's still there.
Oh.
Okay, so now I have, let me give myself some more room to work with here.
And you have to divide by 3, right?
Okay, so then I can rewrite what I have. So now I have x minus 12 equals 3y. What's the next thing I need to do? I want 1y. I want to solve for y. How do I get rid of, what's happening to y? It's being multiplied by 3. How do I undo multiply by 3?
Divide.
Divide by 3. Or, well, that's fine.
Or multiply.
Or multiply by 1/3, either one. So here I'm going to have, on this side I'm going to have y. On this side I'm going to have x minus 12 over 3. So that is my function. So then I'm going to do, I got to call it something else, right? So it's going to be, inverse would be, oh, we'll call it this g inverse, g negative 1. Do you guys remember this notation? I would look up. Remember this notation, the g negative 1? That's g inverse. This means inverse of g. G inverse of x, that means that's the opposite. So you guys remember we did the, right, if it's like Terry, comma, 2004, the inverse, g inverse would be 2004, comma, Terry. You guys remember that handout? So g inverse is equal to x minus 12 over 3.
Or
You
1/3
simplify
x
that one.
minus.
Or you could do, yeah, if you multiply it by 1/3, you could do, because you could multiply by 1/3 instead of dividing by 3.
So x minus 12 would be in parentheses. Oh, yeah, that makes sense.
Well, you don't have to follow both of them. If you're good with either one of these, then that's all right. So let's just stick with this one here. Does everyone understand where we got to, how we got to this spot?
Yeah.
No?
Yeah.
We need to get rid of the 3. Y is being multiplied by 3. How do you undo that? You divide by 3. You have to do both sides. Okay, so here I've got 3 pizzas from Safeway costs $12. Everybody good with this? Yes? 3 pizzas cost $12. Are you everybody with me?
Yeah.
If I divide this by 3, I get 3 pizzas divided by 3 is 1 pizza. 1 pizza is not $12. I have to divide this side by 3 also. So if I have 3 pizzas equals $12, how much is 1 pizza?
$4.
$4. How do you find that? You divide this by, take 12, you divide by 3. Right? So 3 pizzas equals $12. Then divide by 3, divide by 3. 1 pizza equals $4. So you guys are doing algebra all the time without knowing it. Right? It's the same thing. Whatever you do to one side, you have to do to the other side. It's not fair to do it to one side, not the other side. Wouldn't work. Okay, so that's the basics of inverses, which should actually get you through all your homework to this point. We'll go ahead and finish this out on Wednesday.
Can you show the last part of that?
Yeah.
Because I didn't understand the final step.
Oh, up here?
Oh, the next one. No, the below it.
This one? Don't worry about it.
Yeah. Oh.
Fox is just saying,
Oh.
they were saying that you can also, instead of dividing by 3, you can multiply by 1/3. So you know what, I'm gonna take that off because I think it's gonna confuse people.
Okay.
Sorry about that.
So if I do it that way, it's okay.
It's totally fine with me. I think people wanna learn one way, they don't wanna learn two different options.
Yeah, it just, for me, I guess like, when I look at it, the whole divide by 3 just looks weird, so
Okay.
I just divide the.
Yep.
And you can't do it anymore, like the negative
That's
12
it.
divided by 3?
You could,
Because then it would be like,
it'd be 1/3 x minus 4.
12 divided by 3.
Mhm.
Well, 12 divided by 3 is 4, right? So it'd be just x equals 4 or something.
Yeah.
Well, x over 3?
I'm not too sure.
No, I don't.
Computers and oh, they went for multidisciplinary studies. I thought that was all the labs.
1/3, so where are you getting the 1/3 from?
X divided by 3 is same thing as 1/3 times x.
Oh, so you gotta divide them both.
Because I'm not too sure. If anything, I would just follow the loss to see what's it.
Thanks for helping me.
Yeah, no problem.
We don't have to go that far. I wouldn't screw it up. So I would've just did
Well, that's why her way of doing it is multiplying by 1/3 is easier because it gets you to the spot faster.
But you, this,
Sometimes it's hours or
above that is the final where you want us to go, right?
Yeah,
You
I'm
don't want
good with
us to go
that.
any further.
I'm good with that.
Okay,
Yeah.
really just depends on.
okay.
This makes it a little bit easier to see that this is the same thing as f.
Because it depends on the
Okay.
where they are. Or the schedule.
Okay, and guys, I gotta get to my next class, so.
Hey Sam, do you know what the math lab service
The what?
is? Is there a math lab?
The camera's still
I
on.
don't think so. Oh, sorry. Thank you.
There used to be one, right?